We previously discussed parity, which is an error detection scheme sort of for small units of data like a byte. Now we want to look at sending sort of more data and introduce the error detection scheme called checksum. So we're going to be, again, transmitting data, but we're going to be transmitting more data in this case. And so we're going to take the data that we want to transmit. We're going to break it up into units, let's say 16-bit units. And then we're going to sort of add up the numbers corresponding to those 16-bit units, sort of ignoring any overflow that might occur, and then see the result. So we take our data, our whatever thing we're trying to communicate, some message, and we break it up into 16-bit units. We add them up, and then we are going to send the data, and we are going to send the sum. I'll modify that in a little bit. And then the receiver of the information will do the same calculation. They will take the data, they will add it up, and if the sums match, then they will assume that the message came through without error. It was a successful transmission. Okay. Now we do something, I mean, in real life, they do something slightly more clever. So they do they do calculate the sum. They break it up into the 16-bit units and add them up. But instead of transmitting the result of that sum, they sort of take the negative of that sum and transmit that. So then the receiver does the sum with that check as part of what is summed. And because that number is the negative of everything that came before, then the result should be 0. And this simplifies the detection on the receiver's part because it's easier to look for zeros. Just electronically, if you have, in case we kept talking about 16 bits, I would need a 16-bit OR gate. But if I have any one, if I'm looking for a 0 and anything is a 1, then it's not 0. So that makes it a fairly easy thing to detect. So that's why we send the sort of negative of the sum rather than the sum to make the receiver's life easier for detecting the error. Okay, so with the 16-bit error, then the answer, again, we're ignoring sort of any overflows that might occur. So the answer is a 16-bit number, and so there are 2 to the 16 possibilities for a 16-bit string. So was that 65,536? And so if the errors were just random, then you would expect, if there were an error, then you would expect to catch it, 65,535 out of 665,536 times or so. So you would expect to catch any error that did occur 99.9985% of the time. That's if errors are random. Now, errors are not always random, and so we will talk about that when we get to CRC. There are things within CRC to and you can engineer CRC to catch certain kind of errors better than others. And we're not going to talk about it in that much detail, just saying that that is the case. Okay, but here we are in checksum. The we break it up into 16-bit numbers, we add them up, we actually take the negative of that number, we send it to the receiver. The receiver does the calculation. Hopefully it transmitted correctly. If it didn't transmit correctly, uh, it's conceivable that an error occurred, but that the checksum passes. But that should be rare according to this. We should be catching errors, again, 99.99% of the time. Okay. Just showing you that where the such thing arises. So it is part of the internet protocols. So the IP datagram protocol has a uh, checksum in the header. And so that is an error detection scheme to sort of see if the, when you're using the internet and you're sending these IP datagrams around, uh, did they arrive safely? Were bits flipped along the way? Then that IP datagram hands its data up to a higher level in TCP/IP, the TCP segment, and it has another check. So there's sort of in this system of uh, internet protocols and layers, there are checksums at different layers. Now we said that if the problem was a random error, we're catching it most of the time, but not all errors are random. If the error is not just, if the bits that might get flipped are not sort of completely random, but might have some kind of pattern, then we talk about there being a burst error. So there might be, bits that are together that get uh, flipped, or some kind of pattern like the first bits in a byte or something like that. So um, in our next error detection scheme, we will be mentioning, which will be CRC, we will be mentioning that it can be engineered to maybe help a little bit better with particular kinds of burst errors. That's it for this one for checksum. Just add up the digits and the negative, check to be that on the receiver side that the check is 0. This is done in internet protocols at least 2 levels, the IP level and the TCP level. Thanks for your attention.